Hello everyone. Let's see this proof on segments. The given says that segment AB bisects segment CD in M. And I have to prove that CM is equal to DM. So let's look at this drawing. I have segment AB, this one right here, and it says that it bisects this segment, segment CD, and it bisects it at point M. Now let's review the definition of a segment bisector, because in this case segment AB is a segment bisector. The definition of a segment bisector says that it is a segment, a line or a ray that intersects a segment at its midpoint. So according to this definition, I can very quickly state something, or I can very quickly conclude that if AB bisects CD in M, then I can conclude that M is the midpoint according to the segment bisector definition, which says again that a segment bisector is a segment, ray, or line that intersects a segment at its midpoint. So I can conclude M is the midpoint. Okay? And if I say M is the midpoint, I can very quickly say that CM is congruent to DM. Why? Because the definition of midpoint says that a midpoint is a point that divides a segment into two congruent parts. So if M is the midpoint, then I can conclude further and say that segment CM is congruent to segment DM by the definition of midpoint. So I see where this is going. I've reached the conclusion where segment CM is congruent to segment DM, and my proof statement is stating that CM is equal to DM. Now remember, congruence is for figures and equal sign is for numbers. So the final step would be to say that CM is equal to DM by the definition of congruent segments. So there you have your plan. You know how to get to the proof statement. Let's start writing our statements in our statements column. For my first statement, I'm going to write the given. Segment AB bisects segment CD in M. And this is given. For my second statement, according to our plan, I said, well, if this is given and this is true, I can very quickly say that M is the midpoint. M is the midpoint according to the definition of segment bisector. That says that if a segment, a line, or a ray bisects a segment, that means that it intersects the segment at its midpoint. So I can state that M is for sure the midpoint. And this the valid reason for statement number 2 would be the definition of a segment bisector. That would be the valid reason behind me saying that M is the midpoint. For statement number 3, if I say M is the midpoint and I've provided proof on how I concluded that it's the midpoint, then I can also conclude that segment CM is congruent to segment DM. Why can I conclude this? Well, because if I state M is the midpoint, the definition for midpoint says that the midpoint is a point on the segment that divides the segment into two congruent parts. So I know that CM is congruent to DM according to the definition for midpoint. So I'm going to write that definition of midpoint as my valid reason for stating that these two segments are congruent. Whoops, and I wrote 4 here. This should be 3. As my fourth statement, let's see. I said AB bisects CD and M. I've stated M is the midpoint. If M is the midpoint, then these segments are congruent. And if these segments are congruent, then their measures must be equal. Okay? And how do I know this? By the definition of congruent segments, which says that if two segments have the same measure, then they are congruent. And remember, definitions we can use forwards and backwards. If two segments have the same measure, then they are congruent. If two segments are congruent, then they have the same measure. And there you have it. You've reached your proof statement. I'll see you in the next video.